Question 2 then wants us to find the y value when x is pi by 8. So basically put pi by 8 into the expression that we're given and work out the answer. If you don't get this, the first thing to do is to check that your calculator is in radians. Notice it wants the answer given to 5 decimal places in this case. Part B then says to work out the area under the curve using the trapezium rule. So my area is going to be half of the interval, where the interval goes from 0 up to pi by 8, so that's pi by 8 is my interval width, into the first value, which is 0, plus the last value, which is also 0, plus twice all the others. So that's 2 lots of 0.73508 plus 1.17157 plus 1.02280. And again, all that goes in your calculator, and the answer comes out to be 1.1504, answer to 4 decimal places according to the question. Part C then asks us to integrate the given expression using the substitution u equals 1 plus cos x. Remember, the first thing you want to do here is to differentiate this. So du dx, differentiate 1, you get nothing. Differentiate cos x, you get minus sin x. So rearrange this to say dx equals something, and dx is going to be equal to du divided by minus sin x. So I need to come back to my integral here. Now my sin 2x on the top, I need to get rid of the 2x as the angle, so I need to write this in terms of single angles. So this is going to be the integral of 2 lots of 2 sin x cos x over 1 plus cos x. And now to do my substitution, what I'm going to end up with here is 2 2s are 4, so I leave that where it is. I've got a sine here on the top, but I've also noticed I've got a sine in the denominator here when I replace my dx. I'm going to leave the sin x there for the time being because I know it's going to cancel out. I've then got a cos term here, so if I come back to my substitution, I can rearrange this to say cos x equals u minus 1. So I can replace my cos x by a u minus 1. My dx then is getting replaced by a du over minus sin x. And then finally, the 1 plus cos x on the bottom is replaced with a u. Now I can cancel my 2 sin x terms, and I've now got my integral completely in terms of u. So let's simplify this a bit. I've got a minus under 4, then I've got u minus 1 over u integrated with respect to u. So if we sort out this fraction here, this gives me minus 4u over u, so that's just minus 4, and then minus 4 times minus 1 gives me plus 4 over u, and I'm now at the point where I can integrate. So if I integrate minus 4, I get minus 4u, and if I integrate 4 over u, well, think of this as being 4 times 1 over u, so this is 4 multiplied by the natural log of u. Now I need to substitute my my x's back in here, so this is going to be minus 4 times 1 plus cos x plus 4 lots of the log of 1 plus cos x plus a constant. Now if you look at what you're given, there's no minus 4 here, yeah, in the answer that's given. So if we expand this out, we get minus 4 cos x plus 4 natural log of 1 plus cos x plus my constant. So we want this term, that's in the given answer, and we want this term, that's in the given answer, but the minus 4 isn't there. But we've got a minus 4 here and a constant on the end, so if we combine the minus 4 with a constant, all that happens is we get another constant. So if minus 4 plus my constant is equal to a different constant, then what I end up with is 4 natural log of 1 plus cos x minus 4 cos x plus a constant that I'm now calling k. Part E then wants the error in the estimate, so the first thing we need to do is to work out the actual answer. So I'm going to take my 4 log 1 plus cos x minus my 4 cos x from the answer to part C. I'm ignoring the constant because this time I'm going to put some limits in, and my limits are 0 and pi by 2. So if we substitute in pi by 2, we get 4 log 1 plus 0, cos pi by 2 is 0, minus 4 times 0. And then if we substitute in 0, we get 4 log, well, the cos of 0 is 1, so this is 4 log 2, and then minus 4 times cos of 0 is 1, so 4 times 1 is 4. So if we simplify all this, log of 1 is 0, so this term goes away. This is 0, so we end up with minus 4 log 2 plus 4. So 4 minus 4 log 2. And if you work this out to 4 decimal places, the answer comes out to be 1.2274. Just put it in your calculator. So the error then is going to be 4 minus 4 log 2, take away 1.1504. So 0.077 would be your error in your answer.